Hi, my name is Radhika. Welcome to my additional mathematics classroom. Today we will do this paper, 2021 May-June paper 13.
Let's go to question number 7. A. A committee of 8 people is to be formed from 5 teachers, 4 doctors and 3 police officers. Find the number of different committees that could be chosen if part I, all 4 doctors are on the committee. Okay, we need 8 people. Okay, we have 9 plus 3, 12 people. So out of 8 people, all 4 doctors are on the committee. That means let's imagine the chairs for the people like this. So all 4 doctors will have to be there. That means we have the choice for the 4 remaining seats. And how many people do we have? If all doctors go, it is 5 plus 3, 8. So we don't have choice for the first 4, but we have choice for the last 4. So out of 8, 5 plus 3, 8 people remaining, we have to select 4 people. So the answer is 8C4. It is 8 factorial divided by 8 minus 4 factorial into 4 factorial. And the answer comes to 70. Now the question comes, why it is 8C4, why not 8P4? Now the answer is simple. We have to go for P when the order of selection matters. Say for example, the 4 doctors are named D1, D2, D3 and D4. If this order matters, if I select D1 first, then D2, then D3, then D4, or if I select D2 first, then D1, then D3, then D4, if I change the order, then if they meant different options, then I should go for P, because the order matters. If I selected D1 and then D2 or D2 and D1, then they count for different options, then we have to go for P. But in this case, in whichever order you select the doctors, it doesn't matter. We have just one selection finally. So that is why it is C. Therefore the answer is 70. Now the II part. There are at least 2 teachers on the committee. So we have totally 5 teachers, at least 2 teachers, meaning we need to have at least 2, but we can have more than that. So we have options for teacher selections like this. At least 2, I can have 3, I can have 4, or I can have 5, because we have maximum 5 teachers. So depending on the choice of teachers here, we will select the other people. So if I write it is other people, 2 teachers, then 6 will be from other people, 3 teachers, then 5 other people, 4 teachers, 4 other people, 5 teachers, 3 other people. So we have 4 options here. Accordingly we will calculate the options available. So if it is 2 teachers, we have 5 teachers, so the options are 5C2. For every option of selecting these 2 teachers, we have 7 people, out of which we have to select 6. So it is 7C6. Now for the second option, if you understand the first one, writing second one is very easy. Out of 5 teachers, we have to select 3, so 5C3 number of options, multiplied by, out of 7 available, we have to select 5, 7C5. Similarly, this will be 5C4 multiplied by 7C4, and the last is 5C5 multiplied by 7C3. Why C here, why not P? Again the same answer how we answered for part 1. Now calculating this one, it gives us 70. 5C3 into 7C5 gives us 210. 5C4, 7C4 gives us 175, and the last one 5C5 into 7C3 gives us 35. So if you calculate the total, it comes to 490. So that is the answer for 7AII. Now there is a method 2 for this answer. We have to think about what is the reverse of at least 2 teachers. So we will see this in little detail. The method 2 for solving this problem. See whichever you find easier, you can go with that. Let us think of the reverse of at least 2 teachers. Can you think of the statement which is the reverse of at least 2 teachers? So yes, you got it right. It means exactly 1 teacher. Do you see that? Exactly 1 teacher is opposite of at least 2 teachers. So the method 1 concentrated on this option. Now we will do this method in this method 2 using this statement, exactly 1 teacher. So reverse of exactly 1 teacher. So what is the number of options for selecting exactly 1 teacher? That is 5C1, exactly 1, multiplied by out of 7 we have to select 7 people. Okay, so this comes to 5 factorial into 1 factorial. This is 5. So we have 5 ways of selecting exactly 1 teacher. So number of teachers is 5, so we don't have to do this calculation, otherwise also it is 5 ways. So it is reverse of, that means out of total options available, if we remove this 5, the remaining is at least 2 teachers. So what are the total options available? How many people do we have? 12. So it is 12C8. This is the way in which we can select 8 people out of 12. From there, if we remove this 5 ways, that is exactly 1 teacher, what we get is at least 2 teachers option. And let's calculate how much this comes to. 12C8 minus 5, yes, it comes to 490. So this is a very easier method. You just need one calculation only, but you need to be careful to form this reverse statement. 7b, given that np5 is equal to 6 multiplied by n minus 1 p4, find the value of n. So here we will have to go with the definition of NPR. So what is NPR again? It is n factorial divided by n minus r factorial. So n factorial divided by n minus 5 factorial is equal to 6 multiplied by, observe this 6 is independent of this p, n minus 1 factorial divided by n minus 1 minus 4 factorial. So n factorial divided by n minus 5 factorial is equal to 6 into n minus 1 factorial divided by n minus 5 factorial. So we can see that there is a common denominator on both sides, so we can cancel them each other. So you can think it as also, if you take this denominator to the other side, it will go to the numerator, so there is one bracket in the numerator, one similar bracket in the denominator, you can cancel. So what remains is n factorial divided by n minus 1 factorial, take this n minus 1 to the other side, is equal to 6. So n factorial can be written as n multiplied by n minus 1 factorial divided by n minus 1 factorial is equal to 6. Now you must be wondering why n factorial can be written like this. Let's take an example. Let's say 5 factorial. By definition, this is 5 into 4 into 3 into 2 into 1. What is 4 factorial? It is 4 into 3 into 2 into 1. So can we write 5 factorial as number 5 multiplied by this total, which is nothing but 4 factorial? So any n factorial can be written as number n multiplied by n minus 1 factorial. Same thing what we have done here. N factorial is written as number n into n minus 1 factorial. So we cancel this out. So finally we get n is equal to 6. That is the answer for 7b. Now going to question number 8. The graph shows the curve y equal to a cos bx plus c for x in between 0 and 2.8, where a, b and c are constants and x is in radians. The curve meets the y-axis at 0, 3 and the x-axis at the point P and at point R. R's coordinates given 5 pi by 6, 0. The curve has minimum point at Q. The period of a cos bx plus c is pi radians. Find the value of each of a, b and c. Alright. Part A. The period of any function is given like this. So the period of sine and cos we know is 2 pi. So take 2 pi, divide by whatever coefficient you see with x. This gives the period of any sine or cos function. Okay. So now 2 pi by p is the period of this function, but this is given to be pi. So from here we find that b is equal to 2. Now to calculate a and c. For this we will make use of the intercepts given. There are 3 intercepts, one with the y-axis and 2 with the x-axis. So let's start with the y-axis intercept. So y-axis intercept is 0, 3. That means when x is 0, y is 3. Let us substitute in this equation. 3 equal to a cos b, that is 2. 2 into x is 0 plus c. 3 equal to a cos 0 plus c. That means 3 is equal to a cos 0 is 1. So it is a plus c equal to 3. So this is our equation number 1. Then we will use one of the x-axis intercept, that is point R. So R's coordinates are 5 pi by 6, 0. So we will substitute x as 5 pi by 6, y as 0 in the given equation. So 0 equal to a cos bx, b is 2 into 5 pi by 6 plus c. So 0 equal to a cos, if we simplify this, 2 1 times, 2 3 times, so it is 5 pi by 3, cos 5 pi by 3 plus c. So 0 equal to a into, let's find out what is cos 5 pi by 3. Set your calculators in the radians mode. We will find that the answer is 0.5 plus c. So it is 0 equal to 0.5a plus c is our second equation. Now using equations 1 and 2 we will do simultaneous equation solving. So let's do 1 minus 2. So when we are doing minus 2, the second equation's sign will reverse. So plus c and minus c will cancel each other. So 1 minus 2 gives a minus 0.5a, we get 0.5a equal to 3 minus 0 is 3. So a is 3 divided by 0.5, which is 6. Now we substitute this value of a in 1. So it is a plus c, which is 6 plus c equal to 3. So c is 3 minus 6. So c is minus 3. So we have all the values of a and b and c. So let us summarize. A is 6, b is equal to 2 and c is minus 3. So this is the answer for 8a. Going to question 8b. Find the coordinates of P. P is the first x-intercept. So our equation after finding a, b and c values are y is equal to 6 cos 2x minus 3. Now at point P we know that it is an x-intercept, so y is 0. So we will make use of this fact. So 0, substitute 0 in place of y is equal to 6 cos 2x minus 3. So rearranging take this 3 to the other side, it becomes plus 3. So cos 2x is, from here, cos 2x is equal to 3 over 6, which is 1 over 2. So from here it follows that 2x is cos inverse of half, and your calculator will give you the value, it is pi by 3. Therefore x is pi by 6. So the coordinates of P are pi by 6, 0. That is the answer for 8B. Now part 8C, find the coordinates of Q. So Q is the minimum point of the graph. Alright, so we know any minimum or maximum points, that is the stationary points of a graph, can be obtained by differentiating the equation of the graph with respect to x. Alright, so we have the equation of the graph as 6 cos 2x minus 3. So to find the stationary point, I am repeating, we have to differentiate the equation of the graph with respect to x. So dy by dx is equal to 6 multiplied by the differentiation of cos is minus sine 2x. Then we have to differentiate 2x, which gives us 2, minus d by dx of a constant is 0. Okay, so it simplifies to minus 12 sine 2x. 6 into 2, 12, this minus sign here. Now the stationary points are the ones where dy by dx goes to 0. That means this expression going to 0. So sine 2x is 0 because 12 cannot be 0. So sine 2x is 0. This gives us the value 2x is equal to sine inverse of 0, and the first value, the calculator value, which is the principal value, is 0. Then how do we find the second value? You just do 180 minus the first value. So 180 minus 0 or pi minus 0. 180 or pi is same. The second value is pi. So we get two values. This is principal value, which is what your calculator is returning, and this is 180 minus principal. So since we are operating in radians here, it will be pi minus principal, which is 0, so it translates to pi. Now after we get two values, we can get two more values for each of these by doing plus 2 pi minus 2 pi, and for the second value plus 2 pi minus 2 pi. So plus 2 pi plus 0 we get 2 pi, minus 2 pi and 0 we get minus 2 pi, plus 2 pi 1 pi we get 3 pi, minus 2 pi 1 pi we get minus pi. Now we have 6 values altogether. 1, 2, 3, 4, 5, 6. So the value of x is given to be from 0 to 2.8. That means obviously the negative values are not in the range. So we will discard this one, we will discard this one. So we have 4 values, 0, pi, 2 pi and 3 pi. So these are the 4 values that we selected based on the range given. So x is equal to, just divide each of the values by 2, 0, pi by 2, 2 pi by 2, 3 pi by 2, which is 0, pi by 2, pi, 3 pi by 2. Remember, we are now calculating the coordinates of Q, right? So Q is in between P and R. What are the coordinates of P? We found in the previous part, it is pi by 6, 0, and R is given, which is 5 pi by 6, 0. Now Q is a point which is in between. So can x equal to 0 be the x coordinate of Q? No, it cannot, because P itself is pi by 6. Pi by 6 is 0.16. Okay, so this is 0.16. So this x is equal to 0 is to the left, but in the graph it is clearly shown Q is to the right of P. So this cannot be. So can it be pi by 2? Yes, because this one is 0.166 pi. Pi by 2 is 0.5 pi. So definitely this is to the right of 0.166. So we will select this value for x for finding the coordinates of Q. So with x equal to pi by 2, let us calculate what is the y coordinate. We will substitute in the equation of the graph. So it is 6 cos 2x, which is 2 into pi by 2 minus 3. So 6 cos 2 and 2 cancel, pi minus 3. So 6 into cos pi is minus 1 into 3. So it is minus 6 minus 3 minus 9. Therefore, the coordinates of Q are pi by 2 comma minus 9. So verify pi by 2 is to the right of P, yes. Minus 9 is in the negative side of Y, that is also right. So always if there is a chance to verify your answer, please do. So that is the answer for 8C. Question number 9. A. Show that the equation of the curve y equal to x square minus 4 into x minus 2 can be written in the form x cube plus ax square plus bx plus 8, where a and b are integers. Hence find the exact coordinates of the stationary points on the curve. So what are stationary points again? Stationary points are the points where the curve turns. So it can be a minimum point or a maximum point. Say for example, a curve is like this. There is a stationary point here, there is a point here, there is a point here. So the point where the curve is taking a turn is a stationary point. So a stationary point can be a minimum point or a maximum point. See, this point here is a minimum point because after that the curve value is increasing, the curve is raising. This is a maximum point because after that the curve is declining. Again, this is a minimum point. So there can be multiple minimum and multiple maximum points. So in general, any minimum or maximum points are called stationary points. Okay, and we find the stationary points by calculating dy by dx and then equating it to 0. Let us first find the values of a and b. For that we have to expand this, that is open the brackets. We will multiply these two and then multiply these two. So we get x cube, then minus 2x square, then this one minus 4x plus 8. So comparing it with this form, we can see that a is equal to minus 2, that is the coefficient of x square term, and b is equal to minus 4, which is the coefficient of x term. So dy by dx is equal to, differentiating x cube, we get 3x square. Bring this index down and reduce the x power by 1. So 3 minus 1, 2, minus this 2 into x square differentiation is 2x. Going with the same method, bring down the index and reduce the x power to x power by 1. So 2 minus 1 is 1, minus differentiation of minus 4x is 4 and differentiation of 8 is 0. So this is 3x square minus 4x minus 4. So as we discussed earlier, the stationary points are found by equating the dy by dx expression to 0. So we will find x value, x is equal to, by using the formula minus b plus or minus square root of b square minus 4ac divided by 2a. What are a and b and c? A is 3, coefficient of x square, b is negative 4, coefficient of x, and c is negative 4. Let us substitute minus b plus or minus square root of b square minus 4 into a into c divided by 2a. So this is what it simplifies to. Let us find the two values. 4, so this simplifies to 4 plus or minus root 64 is 8 divided by 6. So one value is 4 plus 8 divided by 6 and another value is 4 minus 8 divided by 6. So it is 12 by 6 is 2, minus 4 by 3, minus 4 by 6 will be minus 2 by 3. So we get two values of x. That means at these two x coordinates we have the stationary points. So let us find the y coordinate for each of these x coordinates. When x is 2, y is equal to, we will substitute this value of x in the equation of the curve. So what was the equation of the curve again? It was y equal to x cube minus 2x square minus 4x plus 8. So let us substitute these values. X equal to 2 in this equation, we get 2 cube minus 2 into 2 square minus 4 into 2 plus 8. So it is 8 minus 8 minus 8 plus 8. So we see that all the terms cancel each other and y is 0. So the first stationary point is 2, 0. Now with the second value of x, we will calculate the y value. So x second value was minus 2 over 3. So y will be, so be a little careful here because you have a sign here, negative, and you have a fraction. So cube minus 2 into minus 2 over 3 whole square minus 4 into minus 2 over 3 plus 8. Okay, so it is 8 over 27, negative 8 over 27 minus, this is 4 divided by 9, 8 divided by 9 plus 8 divided by 3 plus 8. So you can use the calculator to simplify. We will see that this simplifies to 256 over 27. A little weird value, I agree, yes. So therefore the second coordinate is minus 2 over 3 comma 256 over 27. So what is the answer for exact coordinates of the stationary curve? This is the answer. The first coordinate is 2, 0 and minus 2 over 3 comma 256 over 27. So this is the answer for 9A. So just recalling the steps, what we did is we found A and B first. We got a simplified version of the equation of the curve y equal to, then we differentiated it, equated it to 0. We got two values of x, that means two x coordinates of the stationary points. Using each of these x coordinates we found the y coordinate, and that is how we got 2 points which are the stationary points on the curve. Going to question 9b. On the axis, sketch the graph of y equal to modulus x square minus 4 multiplied by x minus 2 modulus, stating the intercepts with the coordinate axis. So you have to sketch the graph here. Now the original equation was like this: x square minus 4 into x minus 2, which we had simplified to be x cube minus 2x square minus 4x plus 8. So definitely this is a cubic equation, and when it is a cubic equation we know the shape of the graph is either this way or this way. So say that again, which one is the shape? Is it the first one, A, or is it B? Who decides? It is the coefficient of x cube term decides. If it is positive, then this is B is the graph. If the x cube term has a negative coefficient, then it is the A is the graph. So in our case x cube coefficient is positive 1, therefore the shape of the graph is like this. Alright, so we need to know the graph before the modulus so that we can draw after the modulus. Now that we know the shape of the graph, let us find out the intercepts. So how do we find the intercepts? By equating each of the factors to 0. So x square minus 4 is one factor. we equate it to 0, we find x is equal to x square equal to 4, and hence x is equal to plus or minus 2. Equating the second factor to 0, we find x is equal to plus 2. So from knowing the shape of the graph, we know the shape of the graph already to be like this. So where the x-intercepts are 1, 2 and 3. But see the values here clearly. We have plus 2, minus 2 and again plus 2. There are no 3 different intercepts. It is just 2 intercepts, 2 different, plus 2 and minus 2. So that means 2 intercepts are coinciding. The plus 2 and the plus 2 are coinciding. That means these two are not 2 different points, they are single point. Okay, so the shape of the graph will become like this. It is just touching x-axis and then goes like this. It doesn't cut x-axis. So let us mark, this is plus 2 and this one is minus 2. Okay, so the x coordinates are plus 2 and minus 2. We have to show the y coordinate now. Okay, now think, how will you find the y coordinate? Yes, you are right. So y coordinate is found by putting x equal to 0. So y is equal to, remember we are still drawing the equation, this equation graph without the modulus. So y equal to, when I put x equal to 0, we get 0 minus 4 and 0 minus 2, it becomes plus 8. So this point here is 8. So we have drawn the graph, we have marked all the intercepts, and that is for this graph. Now let us come to the modulus graph. What do these two lines indicate? It indicates that even though this expression goes negative, we will not consider the negative sign, we will always show the y value as positive. Say for example, what is the value of modulus 2? It is 2. What is the value of modulus minus 2? It is also 2. So that means any expression between the modulus sign is negative, we will not consider the sign, we will still show the magnitude only as positive. So going with that, we have to see here at which value the graph, at which value of x the graph is going to negative. So see here, it is in the positive y direction, this part is positive y direction, this part is positive y direction. Here is the trick, it is going in the negative y direction. So as I said, there is no negative value for y because of this modulus. So that means this part we will have to just show it like this. That means when the modulus comes, there is no negative y value. So it will just go back. So the graph of modulus x square minus 4 into x minus 2 is this one. So we have drawn the graph, we have sketched the intercepts also. So this is the answer for B. Now part C says find the value of the constant k for which this modulus x square minus 4 into x minus 2, that means this y value equal to that k value has exactly 4 different solutions. Let us interpret the question in a more simpler way. We have to find that value of y such that there are 4 different x values for that. Okay, find the values, exact solutions means x values. So find that value of y for which there are 4 different x values. Okay, let's do one test here. Let me say I select this value 8. Okay, so when it is 8, what are the different values of x which makes y equal to 8? For that I have to draw a parallel line like this. Okay, and see where it is cutting the graph. You see, it is cutting the graph in one point, there is one x value here. It is cutting it in the second point, there is one x value here, there is one x value here, and there is one x value. All 4 x values are different. Okay, so that is one sample. Then how about this value here? Again, if I draw a horizontal line, it cuts the graph at 4 values, 4 different places. That means 4 different x values. At this point, same. At this point, same. At this point, same. Exactly at this point? No. At this point, it the line if I draw, which is nothing but x-axis, it touches the graph at one point, at the second point, only 2 points. So that means obviously this is not included. So all the above are included. Go up. So let us say this value here, okay, just below the peak here, just below. If I draw a horizontal line, yes, it cuts the graph in 4 points. How about here? This point cuts the graph in just 2 points. That means this value of y has just 2 different values of x, not 4 different. Alright, now we have almost there near the solution. So what is the value of k? K must be, or the y must be greater than 0 and less than this peak value here, so that there are 4 different x values. Okay, now it is up to us to first find the max value here. So what is this max value? We have already found out. Our stationary points coordinates we have already found out, isn't it? What were the stationary points? Go back and check. So the first stationary point is 2, 0, and the second was minus 2 over 3, 256 over 27. Now do we identify this 2, 0? Yes, this is the point. This is the min point. And minus 2 over 3 is this point, okay, which is minus 2 over 3. This was the max point. Okay, and for the max point, the corresponding y value was 256 over 27. So this value here, this value exactly is 256 over 27. Alright, so now we have all the data ready to set the value of k. So what should be my k value? In other words, what should be my y value, so that there are 4 different x values. So this k or the y value must be definitely greater than 0. Remember, we are talking about the modulus graph. That means this graph, not the other graph. So k or the y value must be greater than 0. So you just go a little up, you get 4 values. Keep going up to this peak point here, but not inclusive of that peak point. Therefore we say less than 256 over 27. Note here, there is no equal to here. It is not less than or equal to. So it is just k greater than 0 and k less than 256 over 27. So this is the answer for 9C. Now going to question number 10. We have a parallelogram OABC such that OA is A, OC is C, the point D lies on CB such that CD equal to DB, CD is to DB is 3:1. When extended, the lines AB and OD meet at point E. It is given that OE is equal to H times OD. H is a scalar, that means any constant, any number, and BE is equal to K times AB, where K is also a constant. Now part A. Find DE in terms of A, C and H. Okay, A is OA, C is OC, and H is relating OE and OD. So note this, because we can find DE in various ways, but the question says we have to find in terms of A, C and H. So the corresponding sides we should make use of. Okay, let's start with the definition of DE. What is DE? The DE vector can be written as OE minus OD. Okay, how do we remember this? The easy way to remember is this: see a point which connects to D and E both. Okay, here the point is O. Okay, so this is the common point for O, for D and E. Now once you find a common point, we have to find an expression for DE. We will go with the E letter first. So it is OE minus, with the common point, OD. The first letter comes later, the second letter comes first. So remember like that. So summarizing, find a point which connects both the letters D and E. Then using that point, write OE minus OD. Alright. Do we have an expression for OE? We don't have an expression, but it is given to us. It is H times OD, H into OD minus OD. So we can simply write this as OD vector is common, H minus 1. Now, do we have the OD expression? We don't have. So let us write the expression for OD. So from the triangle ODC, okay, from the triangle ODC, we can get an expression for OD easily. How do we apply the triangle formula? OD, you start with the first letter here, O, go to C, which is a third point, plus start with the third point and then reach to the last point. So O and D, if you think it like C and C cancel, just think it like that. What remains is OD, what we want. Okay, if there is a common point, we can also write it as OB. If there is some B, we can write it as OB plus BD. Okay, so in this case it is OC plus CD. So OC is equal to C plus CD. What is CD? See the expression here. CD is to DB is 3:1. That means entire CB is 4 parts. Out of that, CD is 3 parts. So it is 3/4 parts of CB. CD is 3 over total 4 parts of CB. So it is C vector into 3/4 of CB vector. What is CB vector? It is A vector. So let us substitute this OD in here. So we get C vector plus 3/4 of A vector, that is OD, multiplied by H minus 1. So we can simplify this one more step further. With H, we multiply this bracket, then minus 1, we multiply this bracket. So it is H into C plus 3/4 of A minus 1 into the same bracket, C plus 3/4 of A. So this is the answer for 10A, the expression for DE in terms of A, C and H only. Question B. Find DE in terms of A, C and K. Okay, where is K? K is in BE and AB. Locate that. So AB and BE, the topmost line, that involves K. So we have to find an expression for DE using that side of the parallelogram now. Okay. Now for DE, how we can include B, A and E? So observe carefully, D and E have both common point as B, right? So like how I explained these earlier, these both have common point B. So how do we start? Start with this common point B, then the second letter BE minus BD. Okay. So I have told you the technique to write the formula with a minus sign. How do we do that? With a plus sign also. Okay. Alright. BE minus BD. Now what is BE? Here it is. BE is K times AB minus BD. What is BD? BD is from here dB. So let us calculate dB. You see, dB is one part out of the total 4 parts of CB. Okay, so dB is 1 out of 4 parts of CB. So it is 1 out of 4 parts of A, which is A divided by 4. That is dB. But what we want is BD. So remember, we are dealing with vectors. So dB is not same as BD. So BD is negative of dB, equal to K multiplied by AB is C vector minus minus plus A divided by 4. So it is KC plus A divided by 4 is the expression for DE in terms of A, C and K. Now let us solve the question 10C. Hence find the value of H and K. Hence find, that means we have to make use of the answers above. So we have found the expression for DE in two ways, right? This was answer for part A, this was answer for part B. Both are expressions for DE. So we will use these two equations to find the values of H and K. See closely, we have H here and K here, and A and C common in both equations. Alright, so we will equate the two. So from here it is HC plus, I am going to expand all the brackets, into H into 3 over 4A minus C minus 3 over 4A equal to this part, A over 4 plus KC. Alright, now what we will do is we will collect all C vector and A vector separately. Okay, so on the left side what we get, C vector common, here we get H and there is one C here, so it is H minus 1 plus, if we collect all the components of A vector we get 3H over 4, then 1 here which is minus 3 over 4 equal to A over 4 plus KC vector. So if the two sides have to be same, that means their coefficients of the vectors must be same. See the coefficient of vector C here, it is H minus 1. Here the coefficient is K. The vector C is same, that means the coefficients have to be same. So we will write this as H minus 1, the coefficient of C vector on left side, is equal to coefficient of C vector on right side. Similarly, the coefficient of A vector, which is 3H over 4 minus 3 over 4, is equal to coefficient of A vector on the right side. Using these two simultaneous equations, we can solve the values of H and K. So from here it simplifies to 3H minus 3 over 4 equal to 1 over 4, or 3H minus 3, take this 4 to the other side, it becomes 4 over 4, it is 1. So 3H is equal to 1 plus 3, which is 4. So H is equal to 4 over 3. We will substitute that here. So 4 over 3 minus 1 is K, which is 4 minus 3 divided by 3, which is 1 over 3, and that is the value of K. So the answer for 10C is K equal to 1 over 3 and H equal to 4 over 3. Great going, my dear. You have reached till question number 11, which is the last question. So do this question, take a nice break and reward yourself. Alright? Yes, let's do the question number 11 now. The line x plus 2y equal to 10 intersects the two lines satisfying the equation. This is intersecting with two lines satisfying the equation modulus of x plus y equal to 2 at points A and B. Obviously there are two lines here. This one line cuts the two lines at 2 points which are A and B. Show that part A C minus 5 comma 20, a point C lies on the perpendicular bisector of the line AB. Okay. Now let us first draw how these lines look like. Okay, that will help this question solve in a more easier way. Okay, this is the Cartesian plane. So x plus y equal to 10. Let's call this equation number 1, and if we plot this, it looks like this. Okay, now x plus y equal to 2. So what does that means? Positive x plus y is equal to 2, or the negative value of the expression inside is also 2. Okay, so let me write this in a different color so that identifying the graph becomes easier. So minus of x plus y is 2. So this is equation number 3, and this is equation number 2. So there are 3 lines cutting each other. The first line is this one. Okay, the second line, the blue line, will be somewhere like this. So there are 2 meeting here. Let's call this point as A. Okay, and the third line, minus of x plus y equal to 2, it is somewhere like this. Okay, so it cuts the original line at point B. Okay, take some time to observe this. This is the original line, the green one. The blue one is the first equation, one line which meets the original line at point A. B is the second equation from the modulus equation we formed, that cuts the original line at point B. So we have got 2 points A and B. Now we have to show that this point C lies on the perpendicular bisector of AB. Okay, now I will just retain points A and B, and then we will draw a perpendicular bisector. So this is the line which joins the 2 points A and B. We have to find equation of the perpendicular bisector. Okay, so these 2 lines bisect each other at 90 degree, and we have to show that point C lies somewhere here. C minus 5 comma 20. So what is the job ahead of us now? We have to find first equation of AB, if possible, or else at least the gradient will help us. Then find the equation of this perpendicular bisector. Then put these values of x and y and see if it satisfies the equation of this perpendicular bisector. Alright, so what are the steps to do this? Let us summarize the steps. Okay, first find coordinates of A and B. Okay, once we find the coordinates of A and B, we can find the gradient of line A and B. Gradient of line AB. We know just 2 points are given. We can find the gradient using y2 minus y1 divided by x2 minus x1 formula. Find the gradient of line AB. From the gradient of line AB, find gradient of perpendicular bisector of AB. How? By using the formula m1 into m2 is equal to minus 1. This gradient, we can calculate this gradient by using the formula here. So once the gradient is clear, find the equation. Okay, so even before finding the equation, we want one point on this line. So find the midpoint, because remember it is a perpendicular bisector. Bisector means exactly in between of A and B it passes. So find this point. So we have to find the coordinates of B, coordinates of A, gradient of this line, the midpoint of the perpendicular bisector, and the fifth step will be find equation of the perpendicular bisector. Now once we get the equation of this perpendicular bisector, checking this point whether it lies on that line or not is very easy. We will substitute x equal to minus y, y equal to 20, and see if it satisfies the equation. Alright, so we have to do these 5 steps to show the first part, that point C lies on the perpendicular bisector. Alright, let's do that. The first step is finding the coordinates of A and B. How do we find the coordinates of A and B? They are the points of intersection of this line with the two lines here. So, okay, let us write the equations here. This is equation number 1, and the two equations that we get from the modulus is, one is positive value of x plus y, which is equation number 2. Another one is negative value of x plus y, that is also 2, equation 3. So from 1 and 2. Okay, so what we do, we want to eliminate x, so let's do 1 minus 2. So x plus 2y is 10. The second equation is x plus y is 2. Since we are doing minus 2, the second equation's sign will reverse. So x minus x cancel. Plus 2y minus 1 is 1y. 10 minus 2 is 8. So x is equal to, from the equation 1, it is 10 minus 2y, which is 10 minus 2 into 8, 16. So x is minus 6. Okay, we got the first coordinate, which is minus 6, 8. Now let us say this is the coordinate of A. Similarly, we will calculate the x and y coordinates of point B. For that, we will make use of equation 1 and 3. Alright, so x plus 2y is 10. So this translates to minus x minus y equal to 2. So actually we are doing here 1 plus 3. We are straight away adding because x has a negative sign along with it already. So we just add, we don't subtract. So these two cancel. It is plus 2y minus y is plus 1y is 12. So you use this 12 value in one of the equations. So let us use this one. X is equal to 10 minus 2y. 10 minus 2 into 12, which is 10 minus 24, which is minus 14. So the coordinates of B are minus 14, 12. So our first step is done. We found the coordinates of A and B. What is our second step? That is, find the gradient of line AB. Let's do that. Gradient of line B is y2 minus y1 divided by x2 minus x1. So the y coordinates difference, 12 minus 8 divided by minus 14 minus of minus 6. So 12 minus 8 is 4, minus 14 plus 6 is minus 8. So it is minus 1 over 2. Now if we call this as M1, the gradient of the perpendicular bisector is M2, then the relation that they share is M1 into M2 is minus 1. So if we call this M1, we substitute minus half. M2 is the gradient of its perpendicular bisector of AB. It is minus 1. So M2 is equal to, carefully shift this minus half to the other side. There is minus 1. 2 goes to the numerator. This minus 1 comes to the denominator. So we get plus 2. So M2 is the gradient of the perpendicular bisector. Now to the third step, that is the midpoint of A and B. Midpoint of A and B, we use the formula x1 plus x2 divided by 2, that is the average of x coordinates and then the average of y coordinates. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So this is minus 20 divided by 2 is minus 10, plus 20 divided by 2 is plus 10. So minus 10 comma 10 is the midpoint. Okay, now we have the midpoint of AB, which is a point on the perpendicular bisector also, and the gradient of the perpendicular bisector, which is 2. So these two are enough for us to find the equation of the perpendicular bisector. Alright, so midpoint is this, and the gradient of the perpendicular bisector was 2. Right? Now considering the perpendicular bisector, its gradient is 2. One point on the line is 10 comma 10. Let us consider other point as just x comma y. This is the way to come up with the equation of any straight line. Okay. Now considering these two are the points on this perpendicular bisector, how would we go about calculating its gradient? We would go about taking the difference in the y coordinates divided by the difference with the x coordinates, right? So that we will do and equate it to 2. Alright, so difference in the y coordinates divided by difference in the x coordinates, and that is the gradient, which is 2. So y minus 10 divided by x plus 10 equal to 2. We will now simplify this. 2 into x plus 10, which is 2x plus 20. Therefore x is equal to 2x plus 20 plus 10. So we get the equation of the perpendicular bisector as y equal to 2x plus 30. So this is what is your reward after doing all the 5 steps. This is the equation of the perpendicular bisector. Okay, now we were ready to show that the point C lies on this perpendicular bisector. So let us test point C now, which is minus 5 comma 20. So let us calculate the value of y if we substitute x as minus 5. Let's see what we get. 2 into minus 5 plus 30, which is minus 10 plus 30. Y value comes to be 20, which is matching with this y value. Therefore C lies on the perpendicular bisector of line AB. Hence proved. Now going to the last part, 11b. The point D also lies on this perpendicular bisector. Alright, as I said, let us have a line already. There was a point C here, minus 5 comma 20. What was the equation of the perpendicular bisector? It was y is equal to 2x plus 30. Okay, let's gather all the information again. M is the midpoint of AB. Okay, AB was something like this. M was the midpoint, which is also a point on the perpendicular bisector. Distance CD, there is a point which lies on this D, okay, on this perpendicular bisector. Let's say D lies here. Now it is given that the distance CD is 3 times the distance CM. Find the possible coordinates of D. Alright, so we will use the distance formula here. What is given? The distance CD is equal to 3 times the distance CM. Alright, what is distance CD? What is the distance formula again? Distance is equal to square root of difference in x coordinates whole square plus difference in y coordinates whole square. So distance is always between 2 points, right? So the 2 points will have x1 y1 coordinates and x2 y2 coordinates. So we'll use this formula. CD, okay, and CM. D we don't know, let us write x comma y. So what is the distance CD? It is square root of difference in x coordinates, minus 5 minus x whole square plus difference in y coordinates, 20 minus y its whole square, equal to 3 times CM. For the coordinates of M, it was minus 10 comma 10. Okay, so we will apply the distance formula here. It is square root of distance between x coordinates cm, so minus 5 minus of minus plus 10 whole square plus 20 minus 10 whole square. Okay, now since there are square roots on both sides, so first thing, let us get rid of the square root sign. For that we have to square both sides of the equations. Squaring both sides, the square root sign will go from the left, so what we are left with is minus 5 minus x whole square plus 20 minus y whole square. Right side we have to square each term, so 3 square is 9, and this square root square, they cancel each other. What remains is, remember this is multiplied to 3 square, so this is minus 5 plus 10 is plus 5 whole square plus 20 minus 10 is 10 whole square, so it is 25 plus 100, so it is 125. Okay, now we will get we got equation in x and y. We need another equation to solve this, because there are two unknowns, we need another equation. Okay, so for that we can make use of the equation of the perpendicular bisector. It is given that the point D lies on this, that means they must satisfy the equation of the perpendicular bisector, right? So we will make use of this, so we will substitute y as 2x plus 30 here. So minus 5 minus x whole square plus 20 minus y is 2x plus 30 bracket whole square equal to 125 into 9 comes 1125. Okay, so this is minus 5 minus x whole square plus 20 minus 2x minus 30, so it will be minus 2x plus 20 minus 30 is minus 10 whole square is 1125. So we will expand this as a plus b whole square is a square plus b square plus 2ab. So minus 5 whole square plus minus x whole square plus 2 into a into b. Plus the second term minus 2x whole square plus minus 10 whole square plus 2 into a into b is equal to 1125. So this is 25 plus x square minus minus plus 10x plus minus 2x whole square becomes plus 4x square minus 100 whole square becomes plus 100 minus minus plus 2 to 4 into 10 is 40x equal to 1125. So x square terms clubbed, we get 5x square. X terms clubbed, we get plus 50x. Then the constants 125 gives 125 equal to 1125. Or 5x square plus 50x plus 125. Bring this 1125 to the left side equal to 0. So 5x square plus 50x minus 1000 equal to 0. We can simplify this by dividing the entire equation by 5. We get x square plus 10x minus 200 equal to 0. Okay, this is a nice equation because we can easily come up with two numbers which multiply to be minus 200, add to be 10. What are those numbers? Minus 20, no, plus 20 and minus 10. These two numbers multiplied give us minus 200, this one. The same two numbers plus 20 added to minus 10 give us the plus 10, this number. So our numbers are x plus 20 into x minus 10 equal to 0. So from here we equate first bracket to 0, we get x equal to minus 20. Equate the second bracket to 0, we get x equal to 10. Now I hope what we were doing finally. We were finding the coordinates, the possible coordinates for D. So that means for D there are two possible x coordinates. Now we have to find the corresponding y coordinates. Alright, using which equation? Using the equation of the perpendicular bisector. What was the equation? It was 2x plus 30. Alright, so we will substitute this x value. Y is equal to 2 into minus 20 plus 30. So it is minus 40 plus 30 is 10. So the first coordinate of the x is minus 20 comma minus 10. Similarly, let us calculate the second coordinate of D. Y equal to 2 into, we will use this value of x, which is 10 plus 30. So it is 20 plus 30 is 50. So the second coordinate possible is 10 comma 50. So the answer for this B is D minus 20 comma 10 and D 10 comma 50.
Thank you for being there in my classroom today. If you need any clarifications on any of the questions that we solved today, you may contact me on my channel in Discord. For more details, please refer to the description box below. Thank you.